We need to prove that 1 plus cotangent of theta minus cosecant of theta whole multiplied to 1 plus tangent of theta plus secant theta is equals to 2. So let's start from the left hand side of a given equation. So on the left hand side, we're going to multiply both of the two expressions. So we have 1 multiplied to 1 plus tangent of theta plus secant theta, which gives us 1 plus tangent of theta plus secant of theta. Next, we have the second term, which is cotangent of theta. So we're going to distribute it to each of the terms. So we have plus cotangent of theta times 1. So that's cotangent of theta plus cotangent of theta times tangent of theta plus cotangent of theta multiplied to secant of theta. And finally, we're going to multiply negative cosecant theta to 1 plus tangent theta plus secant theta, which is going to give us negative cosecant theta minus cosecant theta times tangent of theta minus cosecant theta times secant theta. So this will be equals to, we have 1 plus tangent of theta plus secant of theta plus cotangent of theta plus, now we know that cotangent of theta, that's the reciprocal of the tangent function. So we have 1 over tangent of theta multiplied to tangent of theta plus, then we have cotangent of theta. So cotangent of theta, that's the ratio cosine over sine. So we have cosine theta divided by sine theta whole multiplied to secant theta, and secant theta, that's the reciprocal of the cosine function. So we have 1 over cosine theta minus cosecant theta minus the cosecant theta times tangent theta. Or we can convert cosecant theta to sine theta by taking the reciprocal of sine theta, and tangent theta, that's the ratio sine theta over cosine theta minus, so we have cosecant theta, which will be 1 over sine theta times secant theta, which is 1 over cosine theta. Now let's further simplify this. So we're going to get 1 plus tangent theta plus secant theta plus cotangent theta plus, so 1 over tangent theta times tangent theta, so that gives us 1 plus, we have cosine theta and cosine theta cancelling out, which leaves us with 1 over sine theta, and 1 over sine theta, that's simply cosecant theta minus this term, which is negative cosecant theta minus, we have sine theta and sine theta cancelling out, so we have negative 1 over cosine theta, which is negative secant theta minus 1 over sine theta times cosine theta. Now a couple of terms will get cancelled out. Positive cosecant theta and negative cosecant theta cancelling out. We have positive secant theta and negative secant theta cancelling out. So this is going to give us, so we have 1 plus 1, which will be 2. We have 2 plus tangent of theta. So we can rewrite tangent of theta as the ratio sine theta over cosine theta plus cotangent theta. So this will be cosine theta over sine theta minus 1 over sine theta times cosine theta. Now what we'll do, we'll combine these three terms, the second, third and the fourth term. So their common denominator is going to be sine theta times cosine theta. Now in the numerator, the first term will be sine, that will be sine squared theta. The second term will be, since we already have sine theta, so cosine theta will get multiplied to cosine theta to give us cosine squared theta minus, we have sine theta, cosine theta already present, so this will be, the third term will be negative 1. Now cosine squared theta plus cosine theta, this is an identity with a value of 1. So we have 1 minus 1 divided by sine theta times cosine theta. So 1 minus 1, that's 0. So this entire term goes to 0, and this leaves us with the value 2, which is the expression on the right hand side. So we successfully show that left hand side of the given trigonometric expression is equals to 2, hence proved.